Okay, class, so today we are going to be talking about graphing in standard form. And basically, as we start to go through this next unit, you're all going to be annoyed at me that I made you ever graph from a table. So I know a few of you, Michael and Mason, are probably going, I told you so, I told you so. But remember, the reason why we graphed from a table is because it's going to work for any type of function that we want to graph, whether it's a line or not. So this specific unit that we're looking at moving forward is only for linear functions. All the rules that we talked about before work for any function. So when we're done with linear functions, later in next trimester, we'll be talking about quadratic functions and exponential functions and what that means and looks like. Okay, so we're looking at standard form today. We're focusing on graphing linear functions in standard form. Okay, and when something is in standard form, it will be in the form ax plus by equals c, where a, b, or c can be any number. Okay, if we are not in this form, then the things we're about to talk about won't work. We have to be in this form to work. When we are in standard form, there are two things that we can find. Okay, the first thing that we can find is an x-intercept. And the second thing that we can find is a y-intercept. Now, an x and y-intercept are simply where the graph crosses the x and y axis. So if I'm looking at a graph on the coordinate plane, okay, and I have a line here, okay, this is my y-intercept because it's where it crosses on the y-axis. And this is my x-intercept because it's where it crosses on the x-axis. Now, normally we would name these as ordered pairs. So I might say that this is the ordered pair 0, -4, right? That's this point. But when I'm talking about a y-intercept, I'm going to know that that means my x value is 0. And y-intercept tells me I know I'm on the y-axis. So the only thing that I would need to write down for my y-intercept is the number -4. Okay, the same thing is true for an x-intercept. We just write down the x value, understanding that, for example, this is 3, 0. We know that the x-intercept is 3, meaning that because it's on the y or the x-axis, our y value has to be 0. Okay. Now, here's how we're going to find the x-intercept and the y-intercept just given the equation. So let's say we're given something like 4x plus 6y equals 12. And we want to find the x-intercept and the y-intercept. Okay, we can look up the fancy book definition. Okay, and it's going to tell us all about what's happening, but I want you to understand. Okay, and what it's telling us is that if I want to find an x-intercept means I am on the x-axis, which means that my y value has to be 0. And if my y value has to be 0, that means to find my x-intercept, I can plug in y equals 0. So I'm going to replace my y with 0. So now I'll have 4x plus 6 times 0 equals 12. Now, the key is that anything times 0 just goes away, right? It just becomes 0 when it's gone. And this gives us a one-step equation we can solve. So my x-intercept equals 3. To find my y-intercept, just like we talked about with the x, right? We know we are on the y-axis, which means that our x value has to be 0. So I can plug in x for 0, 0 for x. And so I can say 4 times 0 plus 6y equals 12. And again, 0 times anything gives us 0, so this just goes away. And this gives me a one-step equation I can solve. And I get y equals 2. Now, here's the thing. In the long run, just because we understand that we're plugging in 0 doesn't mean we always have to show the work that we're plugging in 0. So if I say something like 2x minus 3y equals 24, and I want to find the x-intercept. Okay, in my brain I can know, okay, I'm plugging in 0 for y, but once I plug in that 0, that just makes this y part go away. And so I can kind of just cover it up and ignore it. And now I know I'm left with an equation that says 2x equals 24. And to solve 2x equals 24, right, I'll divide each side by 2. This is still gone, right? I'm still ignoring this. And that tells me that my x-intercept is 12. And then to solve for my y-intercept, okay, I know in my brain that I'm going to plug in 0 for x, but I also know that 0 times anything is 0, and so this just gets covered up and goes away. And now to solve this, I'm going to divide each side by -3. And so my y-intercept will be -8. And so often for these problems, you will have no work because most of it is just mental math. Okay, so I want to look at a couple examples and make sure we're okay with this. Okay, so let's say we have 5x minus 2y equals -15. So if I want to find the x-intercept, right, I'm ignoring my y because I'm plugging in a y and that becomes 0. And I'm going to divide each side by 5 to solve. So that tells me that my x-intercept is -3. And if I want to find my x-intercept, or my y-intercept, sorry, I'm going to cover up my x. Again, make sure I'm keeping this sign with it because that tells me that it's a -2. Okay, and I'm going to divide each side by -2. Now this time I don't get an integer value, and that's okay, right? I end up with just a rational number, a fraction. So same rule as before, this is not slope. Slope is the one that has to be reduced in proper fraction form. Since this is not slope, I don't care how you write the number as long as it is not rounded. So when we divide, right, we get a -15 over -2. Two negatives make a positive, so I'm just going to leave it as 15 over 2. But if you wrote it as 7.5 or 7.5, either of those would be fine as well. Okay. Let's say we have 2y equals a 4x minus 40. And we want to find the x and y intercept. Okay, in this situation, we're in a little bit of a bind here, right? We said that we have to be in the form ax plus by equals c. And we definitely don't have ax plus by, right? X and y are on opposite sides of the equal sign. So if we want to be able to find the x and y intercept, the first thing we're going to have to do is get this in the correct form, which means I need that x back over here with the y. So it's going to feel a little bit backwards of solving for y, right? Instead of solving for y, we're moving the x and y together. But we're still going to use those same rules we've talked about, right? To move a positive 4x, I use a negative. These are not like terms, so I cannot combine them. So I just have a negative 4x, a positive 2y, equals -40. Now I'm in the correct format, and now I can start plugging in 0, which is I'm just sort of covering up and ignoring, right? So I'm plugging in 0 for my y to get my x-intercept, which will be 10, because I'm dividing each side by -4. And my y-intercept, I'm going to be dividing each side by 2, will give me -20. Okay, just like anything else, some weird things can happen. So let's say we have x equals 5. And we might say, well, wait a minute, this isn't in the correct form. I don't see ax plus by. Well, there is a y, there's just 0 of them, so it doesn't show up. And that's okay. This tells us that our x-intercept, it's already solved for it, is 5. And we don't see the y at all. So there is no y-intercept in this problem. Okay, on the flip-flop, if I have something like y equals -3, okay, my y-intercept is the one that's straightforward given to me. I don't see an x at all, so I have no x-intercept, right? The graph does not cross the x-axis anywhere. Now, good news is that we can take this information and now graph way easier than we did before. So let's say we were asked to graph 3x plus y equals 9. Before, we were having to solve this for y, make a table, plug in 3 values, find their output values, plot those as ordered pairs, and then create the line. Okay, we don't need to do any of that today. We know we're in standard form, so we're going to find our x and y intercept. So I cover up. My x-intercept is going to be 3. I cover up. There's not even really anything to divide, right? I'm dividing by 1, but my y-intercept is 9. My x-intercept means I am on the x-axis. So I'm going on my x-axis to 3 and making a point. My y-intercept means I'm on my y-axis, so I'm going to 9. And there is my line. A lot less work than we were doing. But again, what we were doing works all the time. This only works for one specific type. Let's say we have 2x plus 1/2 y equals 4. Okay, so my x-intercept, I'm covering up. I'm dividing. X equals 2. My y-intercept, be careful when you're dividing by 1/2. Dividing by 1/2 is really multiplying by 2. So on my x-axis, I'm going to be at 2. On my y-axis, I'm going to be at 8. Now, they don't always have to be lines that go this direction. Those are just the 2 I randomly picked. So let's say now we have x equals 3. Right? We said if we are in this situation, our x-intercept is 3, and that there's no y-intercept at all. So now I'm going on my x-axis to 3, and I need to create a line that doesn't ever touch the y-axis, right? I'm not allowed to touch the y-axis. So if my line is angled at all, I'm eventually going to touch the y-axis. So for there to be no y-intercept, I need to have a vertical line. So flip-flop, right? If I have y equals -5, right? This tells me I have a y-intercept at -5, and I can't cross the x-axis. So if I can't cross the x-axis, I can never touch the x, which means I have a horizontal line.